This is our last topic in trig transformations, and it is sinusoidal applications. You will need a calculator for the last problem. It's a multi-step problem. So if you haven't already, go ahead and pause the video and read this question, and then we'll get into solving the multiple choice. So for multiple choice, it's always, I call it a game. See how many you can eliminate. That way you raise your chances of finding the correct answer. So for this particular problem, we have this yo-yo and it's rotating extremely fast. It says that we have 20 rotations in 5 seconds, all right? So what I want to do is I'm going to focus on, I need to figure out what information I need to solve this, all right? And again, let's figure out what's important and what's not. They're all using sine, which is convenient. And then the amplitude is all 30, so that's convenient as well. So what I want to focus on is what's happening inside the parentheses. That means my b value. So it's my b value that's changing from each choice, which means I already know the old period for sine. It's going to be 2 pi, which means the goal is to find this new period so we can figure out, okay, what does my b value need to be, okay? So already from the get-go, and I know most of you probably will not remember this, we can see that our input is not in radians, all right? Which means there's no pi. There's no pi in our radians. Or I'm sorry, there's no pi in our inputs. And when I do not see a pi in my inputs, that means the pi has to be in the b value. There has to be a radian somewhere. There has to be, or our units of radian somewhere. There has to be a pi somewhere. It's either going to be in your inputs or in your b value. Not both, not neither. It has to be in one of them, okay? So if I think about this, since it's not in my inputs, that means it has to be in my b value. So the choice has to be C or D. But again, you don't have to remember this in order to be successful in an AP exam. It's just a quick little tip. So going back to solving for this new period, I have this yo-yo. It's rotating 20 times every 5 seconds. We want to figure out how long does it take to rotate once. That's all I want. I need the length of one rotation. So I know that it's doing 20 rotations per 5 seconds. And if I reduce this, we have 4 rotations per second. Which means if I have 4 rotations in 1 second, I'm going to have one rotation be a fourth of a second. Because we have 1 second, there's going to be 4 rotations in 1 second, so each rotation takes a fourth of that second. So now we have our new period. So to find the b value, our old period will be its sine, so 2 pi. New period is 1/4. So the question is, how many times does 1/4 go into 2? 8. And then we have that pi. Or you can do I always forget what the quick terminology is. 2 pi times 4/1, and then you end up with 8 pi. That's the quick way to do it. But understanding how does it work, how many times does 1/4 go into 2, we get 8. So that means the correct answer is D. 49, again, you can pause the video to read the question if you haven't already, but I'm going to go ahead and jump into solving this. For this one, we're not given an image. You don't need an image to solve it, but it does help to get a visualization. So we have a maximum at 0.70, and then we have a minimum at 30.52. That looks terrible. We need to see a point of inflection in there. There, closer. All right, so for this one, we need to figure out the values of A and the values of the value of D. Values of A and D. All right, so you can use the formulas if you want to, or you can look at the outputs and figure out what's going on here. Because really, we only care about what's happening vertically. That's what A and D are, the transformations vertically, vertical transformations. So if I look, I have a 70 and I have a 52. So 70, 52. That is the full range of my sinusoidal curve. So my amplitude is just going to be half of this. okay? So from 70 to 52, we have a difference of 18. And if I divide that by 2, I get my amplitude, which is going to be 9. So my A value is equal to 9. And then I can use this to find the midline, which is going to be where halfway of that is. So if I'm at 70 and I go down 9 units, I end up at 61, which is our midline. So we'll have 61 for the D value. There are multiple ways to approach this. As long as you know that your process works, go ahead and use that. Example 50, the average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by the function. And this is for 12 months. Based on the model, which of the following statements is true? Okay, so a couple things we need to recognize is that A is equal to 25.7. B is equal to pi over 6. C is equal to 4. And then D is equal to 61.2. So I'm seeing the words maximum and minimum. So just a quick recall, to find a maximum for a sinusoidal curve, that's going to be D plus A. So your midline plus your amplitude. To find a minimum, that's going to be your midline minus A. So that'll take you A units below the midline, and then the maximum, that will take you A units above the midline. So we're approaching this differently. It's not graphically, but we're going to be using the function in order to find these. So A says the maximum average monthly temperature is 61.2 degrees Fahrenheit. Well, if I want the maximum, and I'll put a little A here. If I want the maximum, that's going to be the midline plus the amplitude. The midline is at 61.2, and then my A value, or my amplitude, is 25.7. Part A is basically saying that this is equivalent to 61.2. That is not true. So A is not true. Part B says the maximum average monthly temperature occurs at 1 month. Okay, it occurs at 1 month. So my go-to is to plug this in and see if I end up with the maximum value. So the maximum value is going to be 61.2 plus 25.7, which is actually equal to, we'll have 86.9. So the question is, will T of 1 equal 86.9? That's the question. I guess let's plug it in and see what happens. There's probably a quicker way, but I'm not seeing it. If you do see it, send me an email or let me know in class so that I can share the joy of not having to work this out. So 25.7 sine of pi over 6, but honestly, it's good practice. I mean, we're going to be doing trig solving later, and we've already done some examples in our ICAs. So if my m value is equal to 1, I get 1 minus 4, which is negative 3, and then plus 61.2. All right, so we end up with sine of negative 3 pi over 6, which is negative pi over 2, and then plus 61.2. So if we think of our unit circle, sine of negative pi over 2, that's going to be here. That coordinate is 0, negative 1. We want the y value. So sine of negative pi over 2 will be negative 1. So that means we end up with 25.7 times negative 1 plus 61.2. Okay, so we already talked about what the values of the mins and maxes are. The minimum will be the midline minus the amplitude. This is the midline, and then we are now subtracting the amplitude because of that negative. So at m equals 1, that's going to be a minimum, not a maximum. Therefore, it is false. Part C says the minimum average monthly temperature is 35.35 degrees Fahrenheit. So to find the minimum, we can do the D, which is going to be 61.2, minus the A, which is 25.7. When we subtract those, we do get 35.5. So C is true. So at m equals 1, that's actually when the minimum is occurring. All right, this is a table. So if you want to pause it to read it, you can if you haven't already. Otherwise, I'm going to go ahead and start solving it. So this question, it's a little misleading. As soon as we see the word regression, we start going straight to the calculator to type things in. But this one does not ask you to solve or find a regression. It's just saying that we are using a regression with 16 iterations, which is going to be, basically that's the period, 16 iterations. Or I guess iteration it's the process of repeatedly applying a mathematical function or process, which refers to a period. So that 16 isn't going to change what we're looking for. It's just saying that it is also periodic, but we can see that it is with that sine regression as well. And this says, what is about the maximum number of nighttime hours predicted by the sinusoidal function model? So we don't know the sinusoidal function model, but we have the actual data, and we can see what it's going to trend towards, okay? So this word about is really helpful. It's like, okay, we're looking at rounding, and we're looking within the general area of what the maximum number should be or could be. So if I look at the values up here, I see an 11, 9, 8, 5, 5, 6, 10, 11. The maximum that I can see in there is going to be these 11s. And they're both going to be about 11 hours, just by rounding, okay? And then I can also see that this is a full period, because if I were to draw a very rough sketch, I'm going from a maximum, and then I'm going to somewhere there's a minimum, and then I'm coming back to a maximum-ish. Again, it's all approximations, okay? But it would be about 11 hours. All right, so here's our last question, and this is the one that you need a calculator for. So let me just make sure that mine is ready to go. There we go. All right, so I'm going to read the question. We'll read the question and then fill out so many ads. We'll read the question and fill out the part A, and then I'm going to flip over to here. I'll read through the question, but I'm not going to leave the calculator, because if I leave it, it clears it, okay? But we'll come back to that in a second. So as you ride the Texas State Ferris wheel, your distance from the ground varies sinusoidally with time. When the Ferris wheel starts, your seat is at the position shown in the picture. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes you 30 seconds to reach the top, 212 feet above the ground, and then the wheel makes a revolution once every 80 seconds. The diameter of the wheel is 200 feet. All right, so we can use all of this information in order to get started with part A, which is to sketch a complete graph. I would suggest you fill out the Ferris wheel circle first, and then from there extract your data to graph the sinusoidal function. So here we have our Ferris wheel. This is you getting on the Ferris wheel. And the problem states that after 30 seconds, you reach the top, all right? So we are going to be revolving around this way. So for these scenarios, these sinusoidal application problems, you want to find the peak, the minimum, and then also the middle, all right? These are the 4 key points that we use in order to sketch out the sinusoidal curve. And it makes sense, because this is your relative maximums, your relative minimums, and then this is where you are passing through the midline, okay? All right, so in order to get this started, we need the coordinate points for these. We need the time and the height at which you reach that. Or we need the height and then the time at which you reach that height. All right, so we are told that you reach the maximum height of 212 feet after 30 seconds. So from here, we're rotating around, and you reach that maximum height after 30 seconds. We're also told that it makes 1 revolution every 80 seconds, and we'll use that a little bit later. And then we're also told that the diameter of this wheel is 200 feet, okay? So this is 200 feet. Now, if the full diameter is 200 feet, and we continue to revolve around the Ferris wheel, that means when we get to this point here, we are halfway through the circle, through this rotation. Or not through the rotation, but we're passing through the middle part of this particular sinusoidal application. So that means I need my radius, aka the amplitude, which is 100. So if I do 212 minus 100, I get the height when I'm at this point here, which is going to be 112. And then I can do the same for getting to the minimum, which means I will have a height of 12 feet. So 212 minus the diameter, which is 200, we get 12. And then over here, we will also be at 112 because it will match the height for the midline or the middle part. As far as the time, we're going to use the revolutions for that. So it takes 80 seconds to make 1 revolution. It takes 40 seconds to make half a revolution. And then it takes 20 seconds to make a quarter of a revolution. So that means between my key points that I will be using to sketch this graph, it takes 20 seconds. So if I'm going from 30 and I'm revolving around to this next point, it's going to take me 20 seconds to get there. So we'll be here at t equals 50. And then the same trend continues all the way around. So we'll have 70. And then if we're starting at 0, that means for this one, I can subtract 20 from my 30. So I get 10. So now we have the 4 key points we need in order to sketch our sinusoidal curve. All right, so the maximum is 112. The minimum is 12, and then our midline is the maximum is 212. And then our midline is at 112. And I'll go ahead and sketch that midline in, just like we did for our other sketches when we wrote equations. All right, in our inputs, we're going to be at 10, 30, 50, 70, and we need 5 key points. Think back to your parent functions. We always have 5 key points. In order to sketch a full cycle, you need 5 key points. So I'm going to add 20 to my 70 and get 90. So at 10 seconds, we're at 112. At 30, we're at 212. 50, we're at 112. 70, we're at 12. And then at 90, we're at 112. So here's the sketch. Again, 5 key points, label your vertical axis and your horizontal axis, and then we're good to go. All right, so now we need to find the equation for this sinusoid. All right, so that means we need our A, B, C, and D. Well, if we look at our sketch, we sketched in our midline. That is going to be at 112, which aligns with what we got for our Ferris wheel. So therefore, the D value will be 112. That is our vertical translation, 112 feet above the ground. Next, we can use this to find the amplitude. If I did what I did before, I go from the midline to the maximum. That is my amplitude, and that will be 100, which is going to be the same as the radius of our circle. That will always be the case for sinusoidal curves. So that means our amplitude or radius is going to be A. Next, we can do our B value. So it tells you in the question, we can also see it in our sketch. It says 80 seconds per revolution. That is your new period. We can also see that we have a event occur every 80 seconds. So we can see that we're starting at the midline and we're increasing through at 10 seconds. And we see that event occur again at 90. So that means the new period is 80, old period's 2 pi. So that means B is equal to pi over 40. And again, since my inputs do not have pi in them, my B value will have pi in them. As far as the phase shift, you can choose. We don't tell you which one to pick. You can pick whatever you want. Now, we have a maximum. You could use positive cosine for that, so that way your c value would be 30, or you can use positive sine, where your c value will be 10. I'm going to use positive sine just because it's a smaller value, it's closer to the y-axis, so I'm going to say that my c value is 10. So this is a function of height and how it relates to time, so I'm going to do h of t. Our a value is 100. I chose to use sine. And then our b value is pi over 40. Phase shift is positive 10, so we'll have x minus 10 plus 112. If you wanted to use cosine, if you are using cosine, which you'll still get full credit, they're the same, they're equivalent. We'll have 100 cosine, same period. The only thing that changes is the phase shift, which would be x minus 30, because you want to see where that maximum is, and then plus 112. Again, either one works. Either one, you can use either one to complete the next two sections for this. All right, so this is when I'm going to go away from the packet, and I'm going to work through the calculator stuff, and then I'll come back and fill this in, okay? Again, with the adds. Okay, so we'll zoom in and try and ignore all of that. All right, so I have my function. Sorry, now it's freezing. There we go. I need to find a better version. I know it's out there. I just comfortable with this one. So we have our function rule. I'm going to use the sine. You can use cosine if you want. So we'll have 100 sine, and then from here we'll have pi over 40. Close parentheses, x minus 10, and then plus 112. And then just be careful with your parentheses there. All right, so part C is asking, when is the third time that you will be 150 feet high or above the ground, okay? When is the third time that we will see that? So that height, that's an output. So make sure you're not plugging 150 into the function rule that we just made. We are trying to find when will you be, as you're on the Ferris wheel, be 150 feet above the ground. So I'm going to type in 150. And what we're going to do is we're going to see, okay, when do these intersect for the third time? That'll be the third time that you're 150 feet high. So I need to make sure that my window is adjusted correctly, but let's see if the zoom will fix it for us. So we'll do zoom 0. It does not. All right, so if I go back to my window, this is a real world application problem, so we're only focused on quadrant 1. So x min is 0, y min is 0. X max, I'm not sure how far out we're going to go. I know that one period is 90, so that means let's try 200. And then as far as the y max, I know the maximum height is 212, so I want to see the full graph, so let's do 230. And then let's see what happens. Okay, there we go. So if I look at this graph, I have these two functions. You are the blue graph. So you get on the Ferris wheel at the y-axis, and then you're riding up to the top. You passed 150 once already to get to the top. And now when you rotate back down, you're passing a height of 150 again. And then you end up at the minimum again. It's kind of like you forgot to get off, or you're riding it more than once. So you're going up again for the second time, but you're going to pass 150 feet for a third time. So we are going to use that third intersection here. So we can use the intersection function. So second trace, and then we'll do number 5. And then first curve, I just want to get close to the third time that we intersect. So I guess let me use this again. So you're riding the Ferris wheel, you're going up. Now you hit the top. Now you're coming back down. You pass 150 again, and you want to ride the Ferris wheel again. So you're going back up, and then this is your third time. So we'll hit enter, enter, enter. Okay, 1, 2, 3, and we get, you will cross 150 feet high at 94.963 seconds. So that's the answer for part D. So for full credit, you would write T equals 94.963 seconds. And then for our assessments, whenever you're graphing, you need to sketch a very rough graph of what you're looking at. So you would sketch just these two curves and then plot the point that you are using. All right. Part D says predict the height above the ground when, and then you're given multiple t values. So don't use the table for this, all right? It could be a little off because you want to make sure that you're getting the best approximation. You can use the trace function if you want, but my suggestion would be to go home. So second mode, and that quits. Now from here, hit alpha trace, and then we're going to use y1. And now we have our function extracted from our list. So we have y sub 1. And from here, I can just plug in these multiple inputs, their t values, and then get where the height is at that certain time. Make sure you're using parentheses. I'm not sure what the glitch is, but when you don't use parentheses, it will sometimes give you the incorrect value. So if I plug 0 into my function, I get 41.289. So that's where you're starting. All right, you're starting at a height of 41.289 feet when you get on the Ferris wheel. And that's from you walk up the stairs to get onto a Ferris wheel and then all that stuff. So you're not actually on the ground when you get on it. Hopefully not, you shouldn't be. So I'm gonna come back, copy that, and then just change my input. The second part says 55. So at 55 seconds, you are at 73.731 feet in the air, or 7312 if you want to round up. And then for the third part, we'll copy this. After 119 seconds, you will be at 188.040 or 41 feet in the air. So if I come back to the notes, so for this one, to get full credit, I would do a quick sketch. We had the blue sinusoidal curve, and then we had our 150 feet, and the point that I used was this. That's all you need to do, okay? So we just want to see what you're looking at. On the AP exam, you will not have to sketch anything, but again, we're trying to over-prepare you, and then if you plan on taking calculus next year, you will be doing a lot of sketching, okay? So this one is T equals 94.963 seconds. And this is what will get you full credit. Graph, T, answer to 3 decimals, units. Oops. And then for the last one, T equals 0. We could say that H of 0 is equal to, we got 41.289 feet. So include the equation with the units. For the second part, H of 55 is equal to 73.732 feet. And then for the third one, we have H of 119 is equal to 188.041 feet. If you want to use the approximation, that's okay as well. Either one is acceptable. All right, hope this video helped. If you have any questions, please email me.